Welcome to Lesson 1 of Swift Memory Management in Chapter 5. You will learn the definition of memory in the context of the Swift programming language. By the end of this lesson, you will learn how objects are initialized as well as destroyed by the operating system. Let's get started. Hello everyone, welcome to Intro to Memory Management. Today in this lesson, let's learn how to deallocate and allocate object with ARC. So what does it mean by deallocate and allocate? Well, it means how to make an object and also how to remove object with ARC. So you may be like, what is ARC? Well, we're going to talk about it along the way. Okay, so what is memory in Swift in the first place? Well, there are two areas we can talk about when it comes to memory. One is RAM and one is disk. So RAM is the place, it's like a fridge. So when you enter something into this fridge, you gotta take away the storage is limited. Okay. So if you want to drink milk, you gotta take away, for example, ketchup. All right. So in order to drink milk, store milk, you gotta take away ketchup. So it's very store limited. But for disk is a storage, like in the backyard, you can store a bunch of things, and you have to walk all the way outside of, but it's gonna take a longer for you to get the milk from the storage, but still you have a lot more space. So when it comes to Swift, when we say memory management, we refers to RAM mostly. Okay, of course there's cache, but that's beyond the scope of this lesson. Let me just say, when you say memory management, refers to managing RAM. So in your phone right now, my phone, which I'm recording with right now, the 3 GB of RAM and also 126 GB of disk. So RAM is actually what we can now manage today. So why is it important to manage RAM? Well, RAM is so much faster. Again, the fridge, when you enter your house, fridge is actually closer to your body than the storage or the backyard. So the same thing applies to CPU. CPU has a closer proximity to the RAM than compared to the disk. So RAM is much faster, so much faster. Also, it's faster to read and also write. But you have to make sure to take out some stuff when you need to enter milk. Okay. So in this lesson, let's learn how to enter milk. Also take out some sour milk so you don't want to get sick anymore, right? So now let's go to the lesson. Let's learn how to manage our fridge. So first of all, I'm going to design a passport to learn how to create an object. Okay. So I'm going to create a passport, create a class called passport. And it contains two properties. One is called human and one is called citizenship. And right now human has not been defined. We're going to create a class called human later. And let's just create a class called human for now, just like that. We're going to come back to it. And let's try to initialize the citizenship. Right now human property is optional, so we don't have to initialize it. The only thing we have to initialize is citizenship property. So self-citizenship. And when you initialize, you're gonna call, hey, this thing had been generated. Okay, but here's the thing: this is a code that you print something when you print this statement when it has been initialized. But you can also print something when the object of password is deallocated. We call it removed from the fridge. Okay, just like that. The init. Print I paper am gone. So this init method get called automatically, but we'll learn when the init method get called in Swift. Okay, well, this statement will get called when you initialize it, but you'll discover when the statement get called. Okay, you'll find out soon. Just bear with me for now. So now let's learn how to design human. Then this human property contains two things. One property contains passport. Right, human may have a passport, right? And passport may have humans too. So now contains passport optional property. So the only thing you have to initialize is a name. When you are making the name generated. All right, everything else should be the same. And we also can have a init method. When this object of human gets deallocated or removed from the fridge, you want to print, hey, I'm gone. Okay, Sounds good. So let's take a look at this. So now let's attempt to create an object of passport, have a passport like that. So now what you're doing is passport, you're entering Republic of Korea, and let's take a look at it on the bottom here. Republic of Korea, passport generated, but you'll see paper, I'm gone. Huh, interesting. So you're attempting to create an object of passport, but the problem is it is deallocated automatically by itself. So when you say deallocate means, or you enter milk here, but all of a sudden the milk is taken away from the operating system, but you wonder why. Why is that happening? Okay, you'll discover the why soon. But how about this way? Do you think it's going to be deallocated with this way? So you've created this passport variable has a reference to this passport object with the name of signature of the Mars, but the passport has been generated, but there's no deallocated message right there. What is going on? What's happening here? Well, in this lesson, we'll discover what the heck is going on, and that's important to understand. You'll discover more and more as we learn more and more. So this is done by a such thing called automatic reference counting, also known as ARC in Swift. Okay, so ARC refers to how Swift attempts to deallocate object when it to free up the space in the fridge. Okay, so let's learn when the allocation occurs. So basically means this thing is used to deallocate object, but you gotta learn the rule. Let's take a look at the rule. We'll discover the rule soon. So first of all, we're gonna create two instances. One is Bobby human with Bobby name, and also passport Republic of Korea. You can enter your country, you can enter your name, doesn't really matter. Okay, so now you have two instances that are not related to each other, okay? But let's try to do this. Let's try to deallocate this. How to deallocate? Well, you can do this way. Bobby equals Neil, passport equals Neil. Then let's take a look at that. Do you think it's going to be deallocated? Oh, cool. Bobby gone, paper gone, okay? So Bobby equals Neil, and the passport equals Neil. Okay, so do you think you're removing? So let's take a look at what's really happening. So now we have a Bobby has a reference to human object. Passport has a reference to passport object here, right? So what you're doing is you've set some sort of this thing happen, right? Now you made Neil, but here's a catch. Remember, this is the most important part. When you set Bobby equals Neil, you're not saying that the object becomes nothing. You're not saying that. You're not saying that passport object becomes nothing. All right, this is assignment. If you remember correctly from the previous lesson, Bobby has a reference to human object. Is that they're not really stored. Passport has a reference to passport object. But when used to this, Bobby equals Neil, that means you are removing the relationship, removing the reference. That's it. It doesn't mean that you're removing the object. It's removing the relationship, the reference. So that means we're removing the tie right there. You're removing it. Okay, that's it. Nothing else. You're removing the tie. You're not getting rid of the object. Well, why is it being deallocated if you're not just simply removing the object? Well, here's the part. Here is the rule when it comes to automatic reference counting. The only rule you have to know, if the reference count becomes 0, or if there's a relationship, the object gets purged out of memory. So what does that mean? So right now, human passport contains one reference from passport, and human also object has a reference from Bobby variable. But if there's no relationship, the object gets deallocated automatically. So that's what happens here. If you can take a look at it. So right now you create this object, but it's being deallocated right away because it has there's no such thing that has a reference to this object. That's why it gets deallocated only after being created, like a couple milliseconds after. But in this case, it's not being deallocated because now passport variable has a reference to this passport object. Okay, that's why it's not being deallocated. This is the only rule you need to know. If there's no reference count, we call it reference count because many variables, for example, you can have var Bob, right? Var Bob may have has a reference to the same object, okay, you may have a reference to the same object. So the human has now reference count of 2, but right now human has a reference count of 1. Okay, so when the reference count becomes 0, the object get deallocated automatically and get purged out of the memory. You know, the sour milk is gone, okay, because no one wants to drink it. Okay, so I think that is the rule you need to know. Again, this is the most important part. You're not removing the object. You're simply removing the relationship, the reference. Okay. Hopefully, you guys understand what I'm talking about. But we don't live in an ideal world. When it comes to Swift, when it comes to programming, there are times you might have to be careful when it comes to reference type, reference counting. Here's why. I'm going to show you a phenomenon which is very common when it comes to programming, that eats up your memory. Waste your memory in Swift. Waste your memory because you're not allowed to take away some stuff. So here's what's happening. So I'm going to create two objects where are called Bob and Bob Passport. And if you remember correctly, human had the property called passport. Also, passport has a property, optional property of what do you call that? Well, of human, right? So now you can do some sort of interconnection like this. Bob.passport equals my passport that human equals Bob. So if you take a look at the diagram, they have some sort of this kind of relationship. So now Bob has a reference to human object, right? And the my passport has a reference to passport object. And then if you take a look at it, Bob.passport equals my passport. So passport object, a property has a reference to the object, you know, the vice versa. So right now, if you take a look at it, this human has two reference counting, and passport also has a 2 reference counting coming from the my passport as well as coming from var passport. Okay, so now let's try to attempt to remove the relationship coming from Bob to human. Let's do that. Let's do that right now. Boom. Okay, for the sake of simplicity, I'm going to. So let's take a look at it. Come on. Okay, so right now the Bob has been generated. Republic of Korea's passport is generated coming from this line 62 and 63. But now if you attempt to deallocate it or set the relationship to nil, Bob nil and my passport equals nil. Okay, let's see. Oh, what's happening? There's no de-init method get called. What's happening here? Well, let's take a look at the diagram. So when you have var equals nil, you're simply removing all the relationship that has to removing the relationship, right? In the past, Bob had the reference to human property, human object, but when you say nil, you're simply removing the relationship. But here's the problem. You see, this two object has a cross reference for human to human and vice versa. So right now, human has a 1 reference counting coming from passport, and the passport has a 1 reference counting coming from human object. So it will never be deallocated. So how can you deallocate this object? There's no way for you to deallocate this object, right? There's only one property, say Bob. You try to set it as nil. My passport set it as nil. Okay, unless you go into this class of itself, when it comes to variables, you're not allowed to deallocate. So they kind of like staying in the fridge like sour milk. You don't want to drink sour milk, but there's no way for you to take away because you tried it, it doesn't work out. Okay, so how do you solve this problem? So when it comes to Swift, you know this thing gets stored over and over. So whenever you make this object, it gets stored over and over. So later, your app will eventually break because this object gets piled, and you don't want it to you don't want that from happening. So we also call this process or this phenomenon as retention cycle or memory leak. Things are not being deallocated even though you wanted them to deallocate it. Right? We call this memory leak. I don't really know why I call memory leak. Leak means something is the water is moving out from the somewhere, but it seems like the wording is wrong, but I guess that's what people say. And we call it retention cycle. Things are being retained, they're not being deallocated. So how to solve this problem? Well, there's one way for you to solve this problem in Swift, okay? I'm going to introduce you to, so the only thing you have to do is have something weak. So right there, call it weak. I'm going to explain to you what it is. So when you have a weak variable right here, what's happening is the relationship goes like this. So right now, passport has a weak property. So passport now is a weak var human, right? Weak var human. And then this var human has a reference to this human object. But when the weak var has a reference to human object, what's happening is this weak does not increase the reference count of human. So from the perspective from the human object, it only has one reference count coming from var Bob. All right, it doesn't count. The weak reference doesn't count in Swift. So when I say strong, that means simply things are every other things. If you're not specifically stating that this is weak, every other thing is strong. Okay, strong. Everything other thing is strong. Strong means it has a reference count of 1, but weak, when it comes to weak, there's no reference count of any. So now let's see what's happening. So now it's being deallocated. Why is that so? Because if you think about Bob is nil, let's take a look at it. Bob. Now you set Bob as nil. Okay. So you have set Bob as nil. When you set Bob as nil, what happens is now human, if you take a look at human has only what? Used to have only one reference count from Bob. But when you set the reference count as 0, human no longer has reference count. Any no longer has reference count. So what happens is it gets deallocated, right? Okay, because again, the weak reference doesn't count as a reference count. And also, by the way, when it's being deallocated, the reference count automatically the reference to something else automatically get removed. Okay, so that's why it gets removed, because it's impossible to have reference from something that doesn't exist. So right now, passport still is alive because, as you know, it has a reference from passport, has a reference to the passport object, so it's not being deallocated. So all you have to do is set the relationship as nil, and here my passport is nil. So let's see what happens. My paper gone. Why is that so? Because you've set the relationship as nil, just like that. So that's why the passport now has a 0 reference count, so it's going to be deallocated just like that, right above. Okay, so that's, you see the process, how things are removed. So now let's take a look at this part. What if, this is option 1. Option 1. So you learn how to deallocate with Bob nil first. But also you can do with option 2A, which is you deallocate my passport first. So let's attempt my passport equals nil. Probably nothing's gonna work. Let's see. Nothing is deallocated. Nothing. Why is that so? Well, let's take a look at this. So what you did was you set the passport equals nil, so you're attempting to remove the relationship above here. But here's the thing. This object, human object, still has a reference from Bob property, right? And also this passport object still has a reference coming from this var passport property. So nothing is really, human still has 1 reference count, and passport has still 1 reference count. But what if you now attempt to do Bob equals nil? Bob equals nil. Let's take a look at it. Boom, Bob gone, paper I'm gone. So everything else is gone. But let's attempt it. Let's learn it. Let's see what happens. So you now attempted to make it as nil, the relationship as nil. But now if you take a look at it, human now contains 0 reference count. Again, with the weak reference doesn't count as a 1 reference count. So human has no reference count, so it gets deallocated right there. And also, as you know, if it's deallocated, it doesn't make sense to have reference from something that doesn't exist. So it also, the relationship also it's over. And now if you take a look at it, the passport has 0 reference, no reference from human, no reference from my passport. So it's also get deallocated like that. At the end of the day, what happens is you want to see something like this, right there. With this beautiful skull face, that's what you want in Swift. You want it to be dead, right? That's what you want, especially when you're working with memory. If you want things to get dead because you want to free up this, if you want to free up space in fridge, you make sure you take out those bad stuff. You want to kill them out, okay? So right now in Swift, so far we learned the theoretical aspect, what it means to manage memory within ARC, and we're gonna learn a lot more about ARC, how this works using closure and delegate. So make sure you're 100% comfortable with closures and delegate. If you're not ready to go with that, you're gonna suffer a lot throughout the entire lessons, and you're not gonna have fun. Well, I'm gonna have fun because I like teaching, but you will not gonna have fun because you're gonna get stuck all the time. So make sure you review delegate and closures if you're not comfortable, and let's keep coding. I like you guys for being here, and see you guys in the next lesson. Boom. First, you've learned the definition of memory in the context of the Swift programming language. If one of your friends comes up and asks you, hey, what is memory in Swift? You know what to talk about. The sour milk, as well as the fridge. Not to mention, you only want foods that are nice and fresh. Secondly, when you set a variable to nil, it does not mean you're destroying the object, you're simply removing the reference. Lastly, and most importantly, it's all about the reference counting. If you want to get rid of them, make it 0. In the next lesson, you will learn that there might be a retain cycle when you work with the delegate pattern. Make sure, please, you are all good with the delegate and data source pattern. If you're good, let's move on to the next lesson. See you there.